Welcome to the day 4 of TSDSI Tech Deep Dive 2022 conference. Today we are live with the session 7 on security, IoT, 5G, quantum context. Starting with some hygiene instructions. Uh, Let me brief you on some of the important instructions. If you have any questions for the speakers, please type them in the Q&A box, and you may also interact with the fellow attendees live using the chats tab during the session. The rest of the hygiene instructions will be available in the chat box. You may like to go through them and follow. So uh, this is the session schedule. We will have an opening remark from the co-chairs and then three keynotes and a panel discussion, which will be followed by the closing address. This session is being co-chaired by Ms. Vinuta Narayan Murthy from Wipro Technologies and Dr. Vireshwar Kumar from IIT Delhi. I'd like to introduce Ms. Vinuta. She is a Wipro DMTS distinguished member in Wipro CTO from the last 3+ years. Her main focus has been the area for artificial intelligence, machine learning, and deep learning. Now introducing Dr. Vireshwar Kumar. He is an assistant professor in the Department of Computer Science and Engineering at the Indian Institute of Technology, Delhi. He also works closely with the Bharati School of Telecommunication, Khosla School of Information Technology, and Center of Excellence in Cyber Systems and Information Assurance at IIT Delhi. Welcome, co-chairs. You'd like to give opening remarks? Over to you.
Thank you. Thanks, Akash. So, good morning, everybody. I'm Vinuta. We'll just, just give a brief on what we can expect as part of this session. As we all know, we know that 5G connections, GSMA states that 5G connections surpassed 1 billion in 2022 and 2 billion by 2025. With these rapid strides in technology, we have a 5G enabled IoT world that can help one monitor their own homes, provide healthcare services even to remote places, feed data at ultra low latency for autonomous vehicles to take rapid decisions. We also have quantum computers that have come in to help you solve complex problems in real time. But how secure is this 5G enabled IoT world in the presence of quantum computers? Today, in the world of IoT, there's a possibility we've also seen instances where malware can attack home networks. There's also a possibility that you can have a sabotage of healthcare systems. 5G with its has come in, which can with lot of taken up over the try to take care of the constraints there in the 3G and 4G issues like encryption, better encryption, ensuring you cannot track people and things like that. A lot of security things have been taken care of 5G. But it also has brought in all this with concepts like network virtualization, network slicing, new technologies which come with their own security challenges. Further, the existing cryptography technologies can be easily broken by quantum. So security is a key aspect so that to ensure inherently that's handled by these technologies so that we can all live comfortably in this world in a secure way and enjoy the technology trends. I would also hand over to Professor Veeresh for his thoughts.
Yeah, thanks, Vinuta, for that introductory remarks. Good morning, everyone. I welcome all the speakers and all the attendees here. So I think we have three keynote speakers who will talk about the different aspects of 5G security, IoT security, and quantum computing related issues. And then we have a nice panel there, an excellent set of speakers there who will discuss the impact of quantum computing on 5G enabled IoT. So I look forward to a nice session. Without any further ado, we should go to the first keynote address. So back to you, Vidita. Thank you.
Thank you, Professor Viresh. The first keynote section is by Joe Isaac from Wipro Technologies. Welcome, Joe. Thank you for
Hello, Vinitha. Hello, all.
Yeah. So I'll just give a brief introduction, just talk quickly about Joe Isaac. He's currently working with the CTO division in Wipro. He has over 28 years of experience in telecom domain. The list is endless. He's distinguished member of technical staff in Wipro, contributes actively to various standards in IEEE and ACM. He also implements solutions which actually helps him define the standards better. And also, not the least, he's also taken care of getting data science into the 5G world, which is wonderful to see. Over to you, Joe, for your session.
Yeah, thank you. Avinuta, I'm just sharing my slide.
Sure.
I hope my slide is visible.
Yeah.
Okay. So the theme, very good morning to you all. The theme I took up today for 5G secure on the 5G security side was instead of looking at the whole standards as the perspective, how can 5G security assessment be a model for implementation of a known or unknown security methodologies within a network or within a telco core network or on a or an for a service provider. That's the area I took up today to have for a small discussion, and that's the basis of my whole of this conversation. So we know that 5G growth is something which we're seeing is the most fastest or emerging technologies for the last 3 or 4 years. We've seen a lot of implementations of 5G going live in places very far, like the AT&T networks or the telephonic networks, or even in India, as much that Airtel has gone live today with 5G. There are trial networks running on, and there's been a lot of importance of data to be one of the most adamant seen acumen around the whole mobile computing industry. We're seeing data, the voice video data converging on the same plane while mobile broadband gets even more popular. So there is a huge outflow, and we have something reached about 500 million worldwide space, so 540 million around the 5G connections will have with mid of the, I think it's July it was about 550 million, if I'm right, around that was the connections done only on 5G. We're seeing faster growth in India as well. We're seeing 5G making its importance into every domain we think of, be it be banking, be it be security, be it be retail, transportation, and everywhere. I think 5G is the name which has been placed ahead. But this brings in a lot more of, a lot more of criticality from an application perspective. When we know that 70% of enterprise want to move towards private 5G networks, while there's a big investment being planned, how can we ensure that these can be secure? How can we ensure that these use cases of the smart use cases can be still manageable when it comes to the whole ecosystem to sustain into one plane, to a common plane? Operators, while are looking to upgrade the networks from 4G LTE to 5G NSA and to SA. Some people want to do a direct SA. What I've seen, I think people doing NSA and initially and then moving to SA. 65% of people of the operators are looking to move very fast, and they're looking at to have people to come and integrate the whole thing for them, because there are a lot of skill gaps when it comes to newer technologies, especially when it comes to 5G ORAN or a 5G, say a packet core implementation, or how will security play its role when it comes to packet core implementations? How will the front haul, mid haul, and back haul have its play to ensure that they are not susceptible to attacks? While there are about a few in the last, I think, 2 years or 4 years, with the open RAN concept coming into the picture, I think about people are looking at, there are some few companies few of the operators who want to run single stack or monolithic stack kind of environment where they have a common vendor. But the larger perspective is to have a open architecture or open technology architecture where they have various different hardware components coming into it, the same plane, because standardization. I think about 23% of operators are looking to manage the whole thing themselves, while there is criticality in that of how they are able to maneuver the whole security across the whole thing. I think from a 5G RAN perspective, I think about 55% investments already operators are putting in today worldwide globally. Private 5G has been 23% last year. It's shot to 36% as of July this year. We're seeing edge becoming very prominent, and edge growing beyond just the 5G edge. It's also the edge. It's also the 5G edge cars, for example, the cars going cloud car, and so each of these car systems are like an edge system to the network. But slicing plays a key role from a 5G perspective. I'm able to secure um, secure the whole protocol using instantiated individual UPF, SMF, and AMF for an instance, while where I have a proper control on the security as such. If there is one of the slices been hacked, I can still bring it down and still have the other slices running as normal. From a list of the security requirements or the larger spectrum from operator perspective, the top three requirements I think which are concerning operators are that larger attacks on the surface due to massive increase of connectivity. Basically, the 5G radios accommodate more users, more dense, they're more susceptible to carry more dense connections, and hence a larger amount of connections, leading to more unsafe environments. Second, that the number of non-passive or the passive or active devices on the network has gone triple fold or five-fold. They've gone with your MMTC protocol in place, with the sensor networks going live, with the IoT networks going live, with most of IoT networks on Azure and IoT, the Fleet platform, for example, where there are a lot of integrations with SOCs on board for cloud car environment, or even for sensors for manufacturing. I think there's a huge amount of scale up happening there on the devices from a manufacturing perspective, transportation, logistics perspective. I think that I think is forms a whole bulk of traffic beyond to carry the whole thing across. The third, I think, the most one of the top three concerns are the how do you manage the entire IoT extension security when it comes to newer devices? You have newer protocols on IoT which is going to take place, and most of these are pushing themselves into the cloud and making their aspire into it. Right. While I've not covered much in the cloud here, but just keeping my focus only on 5G security as such. But there are a huge more, like, for example, there are so many unknown security vulnerabilities when it comes to IGA, for example, when it comes to authorization, man-in-the-middle attacks. How does DDoS play? How anti-DDoS plays an effect here? There are so much of it. I think when it comes in, I think I took the top three only, but if you see the whole percentage, I think between that itself comprises something about 60% of the whole of this. I think that's the area I think we're looking at. How can this be? How can these services be made as simple as possible to address from a EMBB perspective or URLs perspective or MMTC perspective? So some challenges, I think, what we see are in the context of 5G data is that the mobile data traffic patterns have been pretty high, and most of 35% of the networks today carried of the networks carried are for the 5G networks. All in all, that there's a huge transformation on the virtualization, on the softwareization and containerization of the whole networks, which brings in a lot more complexity from a checkpoint perspective. The control points are many, and virtualization of high network functions make it even more tedious. Um, there is a lot of homogeneity and heterogeneity within the whole network. Trying to manage heterogeneous networks is not easy, especially when you have multi-vendor environment within the whole of this ecosystem. With the MBB 5G slices or the MMTC slice or ULG slices in place, we are able to actually make use of dynamic spectrum sharing, DSO kind of environments where multiple streams of sharing. I can actually share the radio spectrum itself in a 5G environment, which actually throws out even more problems when it comes to security, and trying to manage the front haul becomes really difficult. And how can we make sure that these channels can be addressed? Privacy protection is another big area which I think is playing a bigger role. Even more complex when it comes to Europe and places like Europe where you have GDPR restrictions as well. How are you going to make it context sensitive? How are you going to be consent sensitive? Right? These make it even more outrageous. I think when it comes to challenges there. There are a lot more packets, not billions of hackable devices. You've got your smart glasses, name it, and everything is on the world is actually enabled on this whole platform which runs on this 5G network. From a whole life perspective, when I look at the security information and event management, right, there's a lot on the topmost layer that how will the security pattern get itself identified on the whole components? How can these components get integrated in a part of each of these in the orchestration layers? How can the rig controllers ensure that the respective protocols, the respective underlay tunnelings are in place? How can we ensure that these tunnelings, while in place, do not still load the network? Right? These are some big time questions left there. There is no other means other than going with an IPsec kind of tunneling environment. which is what 5G standards also drive towards. When the be the TS 35501 or 33.310 or the TS 33.210, all of these driving the whole 3GPP and towards the 5G security perspective. I think with more of these being virtualized softwares and containerized, the subs the it's throwing itself to be more susceptible to the whole world. While there are a lot of good users and there are still bad elements on the network which needs to be controlled in some form or another to ensure that we have a seamless way of integration with the whole enterprise. When we expand this whole the whole security of this 5G network security across boundaries, I would like to cover them in three areas. One has the physical structure of the network change within the 5G. 5G specs mandate for virtualized software and containerized kind of workloads. While earlier it was not containerized, but now I think the whole thing is moving towards Kubernetes-based virtualized environments. Even more complicated that most of these are moved from private data centers into the public cloud, either hosted on Azure networks or on AWS network, any of these, which pose even more challenges within. So it makes it even more easier to actually adapt. So I'm able to actually connect from anywhere with the network connected. So I don't have to have most of these components in my premises. I'm having a SaaS based availability. With slicing being very close to the 5G's service perspective, it throws up a lot more that in terms of device threats, malware, like Vinita was explaining, malware, for example, sensor susceptibility, for example, TFTP based man in the middle attacks. How do you stop bot based DDoS attacks on the device? Firmware hacks, because most of these software defined radios are are upgraded online, and then there will be areas where certain notifications have been there pretty high last 6 months on 5G networks. Devices like the IoT can be tampered, or even 5G devices can be tampered. How do you ensure that the whole of the air interface attacks can be stopped? I mean, you can have jamming on the network itself. These jams can come from a simple IoT sensor networks, mesh sensor networks, right? It's very difficult to predict from where this would have come out. One way of actually managing that is you have IoT slices, and each of these slices for each customer can be subsliced. So then you have a virtual UPF, SMF, and AMF with an NEF part allocation to it, and you can actually softwareize it and then instantiate it and give it to that. So if you see some kind of spurious activity, you don't actually downhaul the whole network down, but only that slice, the sub slice, can be brought down and relooked into it, or the malwares can be attacked through. Second part is that the whole part of that, the RAN threats which comes from the edge. Given that latency is the core of the applications today when it comes to 5G, be it be a a smart V2X communication perspective, or be it be an application perspective where you have really low latency networks like SOCs in the entertainment space, or SOCs in the game space, or in the car space, where they want most of these vehicles to be monitored. Governments want most of these vehicles to be monitored by them, and hence makes its way to have much more that the rogue node elements will be persisting in the network. How do you stop these kind of RAN threats? There are a lot of backhaul threats like distributed DDoS is quite common in the networks from 4G LTE. We've been seeing this to some good extent. I think identifying spurious traffic has been proactively stopped. How do you have no way other than, since with the control plane, the open and the user plane being open, it is susceptible to sniffing, and then how do you stop the sniffing? How can you do a mech backhaul sniffing? How can you stop that actually? Right? These are some of the backhaul threats. On the packet core, I think you'll see, because of virtualization and slice security being implemented, with APIs exposed, you will see a lot more APIs getting smurfed through the network. IoT core integrations with the cloud networks will open further more issues. While we may still claim that it's neat, I think within the protocol, we need to have some kind of ubiquitous computing security plane to be implemented. How do you control the roaming partner vulnerabilities, especially when you switch networks across countries? Just that you cannot stop at the HLR or the VLR, but within the protocols with the SB architecture, how can I actually have a security component implemented? Well, not all may be on the 5G SA networks, but they may still NSA networks. So you will still find SGI interfaces. You'll find VAS integrations from legacy still available. So this brings out a lot more that the apps vulnerability or the APIs vulnerability would be much more actually stuff on it on, and more. But you have software defined networks running the whole networks. You have you have things like strategy deployment agendas for your software defined radio networks. With the radio networks going software defined, which means that all the changes will get as they make a beta release every 3 months, 6 months using CI/CD platforms. They'll want to upgrade and check how things work. I think these form the whole base for the whole security networks to be threatened off. And how do you ensure that somewhere you can actually form some layer for this? Across, you will find 3GPP requirements. You'll find IEEE requirements. For example, requirements like your datagram transport level securities, or your stream control transfer protocols, or your the Java object encryption systems, Joe systems, for example. All of these form a layer of dependency, form a layer of overhead when it comes to these tunneling. I mean, you're trying to ensure tunneling between the user plane or the control plane. How do you ensure that you still have efficient communication between the radio networks from the front haul to mid haul to the back haul? How do you ensure that you are still able to virtualize the whole of the packet core and still have them to be served to the whole network domain in a manner that the user to user network security is still safe, while network to network have that flexibility to cooperate within the secure networks there. You may still have some kind of secure mechanism, but most of the secure mechanism should not be an overhead to the whole network. And that, I think, from engineering standpoint, that needs to be ensured to make sure that we don't lose much on this. I think I covered three. I will try and cover 3 or 4 slides on from a security side. What is the business need? I think the whole need to ensure that we don't have threats from access network, especially towards the radios, the access the access segment, especially the radio networks, so the macro radio or the micro radio cells. How do I stop that? How do I enable? How to ensure that the roaming between beginner cells, there's no issue when I have a switch over from network to network. There is no much issue. I think that's one of the critical needs today as on date. How to ensure that there is a control plane and a management plane, security being coexisting, to ensure that there is development across the whole ecosystem. How to ensure that the visibility network and real-time threat analysis comes to play. While we want to ensure a resilient system, we want to ensure risk-free visibility and governance. We want to have 3GPP standards to play their role there. Some things like, for example, having a security gateway on your in your FIG NSA on the S1 plane, or N2, N3, or N9 plane, for example. Implementing of virtual firewalls on, say, a Palo Alto firewall or something, one of these, which you can have a virtual in the control plane, orchestrating your needs through the firewall instead of actually directly orchestrating. Gives you more control. We've done a POC with a Malaysian operator. I think that gives even more firmer control there. How do you ensure that you can have a distributed secure gateway within the minor firewall, within the orchestration layer, SMO layer firewall? How do you ensure the parameter firewall and the API gateway firewall are in sync? How do you ensure that policies which you derive in an orchestration layer make sure it is much more regularized? While you have layered orchestration in 5G, is it time that we look at choreography based implementations where you have even more control beyond the layered protocols, right? How can I look at that? I think IPv6 is looking the 6G network is looking partly at that. Given that we have no other means other than TLS and IP security as one of the forms to ensure that you have security placed within the whole of the packet core or the radio infrastructure within the network. Second, I think the next successful part is the ORAN part. I think you'll find that you need to ensure that each interface, if the E1 interface or the F1 interface or the E2 interface, needs to be secure when they communicate with the packet core protocols, ensuring that there are mutual authentications between your certificate-based authentication between the networks, ensuring that you have datagram protection at all levels, ensuring that you don't have man-in-the-middle attack, ensuring you have trust-based protocol within the exact thing, and trying to get the security of the whole cloud aligned. Neuron systems, half of the systems today are running the cloud and remaining on premises at the network. Edge plays another big role in 5G, and how do you ensure that most of the dynamic orchestration is going towards edge, like the movies, for example, wherever you see things like say a T20 match being played, people watching streams, and then they were able to push this entire stream to the Mac and then stream it from there to the nearest user. I think it opens more for the roaming interfaces. It was more for breakouts, F3 breakouts, or where how do you ensure that security these are the areas I think roughly you can see that how can you manage out. Some things around the private 5G network is getting even more critical. I think with mass adoption of private networks from operators, I think there is some amount of thrust on that, and this is gaining its importance. I think more than India, I think Europe is actually going big way on private wireless because of your factories getting automated big time. I think it's posing a bigger challenge there. Some things like, for example, how do you ensure that the NSA is not susceptible to or not vulnerable to DDoS, for example? Hacking is going to be as far as much as the net today. I think with more of TLS or HTTP to secure protocol communications, I think you're able to control to an extent. Slicing configuration errors can throw much more of connectivity problems of attacks where these slices can actually themselves give up by DDoS attacks. Millions of IoT devices being connected and rebuffering back onto on the protocol, leading to traffic on the routing points. I think today with some amount of spurious networks in, you can actually drop the packet. But then from a third-party perspective, how much will users be okay for it? There are some of these areas I think we'll look at it in deeper. There are a lot of people like Startup who made comments about how they should look at all this and what are the kind of areas they bumped into. This is all throwing up a big security feature list for us, right? From a non-access stratum confidentiality perspective, from a home control enhancement perspective, from an access agnostic network. If I have to have 3GPP and not non-3GPP, support from unmanaged or a managed or unsecured connection, how to manage it? How do you ensure that the user plane protection versus the control plane protection integrity is enhanced? How can I ensure that the privacy protection from a SUSI, from a public-private key anchors or a trust model anchors the whole thing out, right? So there are a lot more, I think, from a perspective that how to ensure that the security edge protection proxy can ensure that a lot more things are placed in and we can explore. There are some kind of assessments like there are these mandatory assessments which we do typically for operators from an deployment perspective. We try to do the radio access network assessments, and these are continuous assessments, 5G packet core assessments on the protocol itself. We flash that, we strip the packet and see what happens at the MEC side, the APS security side. The WAF planes are even more complicated, I think, when it comes to app smearing because of proxying. But you still have control on it. You have some control plane. The tunneling protocols and the control on the user plane gives even more some amount of padding. But I think the firewalls will be very. They have to be particular about of viewing these. The N6 security, for example, the SASE breaks gives out some more breakout features, but then it's still susceptible. I think you need to have an idea system to manage the whole of this thing. So we have a maturity framework where which is repeatable, defined, managed, and optimized. You initiate the assessment on the technology, the architecture, and the deployment and the rollout. You from documentation to interviews to vulnerability scanning, regular scanning at odd intervals, risk identification, moving the risk levels up on the register, scoring it and kind of managing the recommendation. And day by day this changes. So some of the guidelines there are how do you ensure that you have a 5G security design on the data plane, control plane, management plane, and these three becomes very critical when it comes to managing 5G rollouts. Testing the whole security is again, it's a round the clock basis. It has to be done in a factory as manner where you have an orchestration layer to manage the entire the penetration testing or the security audit, for example, or the VA assessments and proactively checking it. I think these things are all moving to AI models, and hence it moves much more active, precise. We can test out how do you do analytics and how do you read this back with data science to see how the repeatability of these threats can be. How do you threat modeling on the fly, dynamic threat modeling, and risk tagging it, and then ensuring dropping packets there. How do you do secure operations around it? One of the approach we use is to envisage it, evaluate it, envisage it, and ensure it. So this is the 5E model where we define where we said that we're able to actually do some amount of visioning, some amount of evolved day-to-day controlling the whole thing, assimilating the whole access to rev model, ensuring that we are able to explore areas within the 5G core, the 5G O-RAN, the 5G network stacks within the whole thing and aligning with the standards. Aligning with standards gives some amount of comfort because protocols are much fixed, and then you're able to do it. So it needs completely a sponsorship buy-in from the CIO office, the CTO office, or which drive most of these. The 5G blueprints have to be updated every day or every week. Given the risk assessments you go through within the whole thing, some of the use cases which make its importance here are on the core and the access networks. You have a lot of these abuse that happening on the network where you have eavesdropping, interjection, for example, hacking, for example, vulnerabilities of the 5G RAT or the RAN, the terminal or the RAN side. Shared infrastructures have even more potential, especially when you try to do sharing of spectrum. You'll have even more issues at the access region, and then that's one of the issues. Second is, I think, when you used to do distributed edge environments, especially after the DU, then you need to be CU, you need to be extremely careful of how the edge nodes overlap, and how do you ensure the slicing is in place, how do you ensure that you don't have data centers being abused using virtualized. These are all cases to make sure that you have a 24/7 rollover on 5G security and compliance, and these things have to be a living model. This doesn't stop in a day or two. This each day there's a learning, and that's why I said implementing of data science algorithms is the best way to take this forward. Typical assessments take the way we drew out is what that you have 1-2 weeks of a blue stick at a dipstick based assessment where you where it's a question based assessment and a snap view of the entire network. You're able to say what is the kind of environment you're at, and a 2 months assessment on each domain of the top of or the technical component, and 3 to 6 deep down. And then once the report is in place, the risk are identified every intervals. I think across every year to 6 months there is a repeatable test continuing going on, which makes it based out. Some things I think are governance to ensure that there is a secure way of managing the whole of the risk, the governance, the security architecture from an infrastructure perspective, from a security standardization perspective, from a CUDU design, the cups, the slicing, for example, enabling automated security platforms using DF. I would still think that data science algorithms are better than AML here, because you have a trained data, and every day the training makes it even more intelligent and better in functionality. And that's one area where we are also looking much into it. How do I ensure that the SG interface or G interface or N6 interfaces are much more hardened? How can I ensure that zero trust hardening product can be in from a service perspective? How can I ensure that I have a secure planning from the security to the risk to a security architecture from end-to-end perspective, and updating your technology at regular intervals and secure operation? I think that's the thing. To end up the slide, I think I just put up into 4 things. That one is the design of security has to be around. It cannot be just that the protocols. It has to be from the learning of the networks. The networks learn, hackers learn day by day. So the pattern of how your network behaves becomes very critical. Hence, calls for audits. There are threat modeling which happens on a daily basis. Though the threat what you see on a web is not the same what you see on a radio interface, for example. You should be able to model each of these and bring it forward. These architecture inputs give you a lot more insight and be able to manage better. From a platform security, especially when it comes to NFVI or the cloud infrastructure, I didn't address cloud from a public cloud perspective, but that's even more that because they will cover that part of it and the remaining they will not cover. So how do you holistically cover that part of it? How do you ensure that you have a complete network security from your transport to your applications managed through the rig controller or the orchestrated network plans? How do you ensure the entire security testing is in place? I think with all of these 4 together, I think you'll be able to achieve some amount of sensitivity in the whole this and manage this through. I'd like to conclude saying that security is a daily affair. Security network security, especially in 5G, 6G networks, will be a daily affair going forward. And if you are able to model the whole of this using data science algorithms, this is the best way to go forward. And you're able to actually predictively figure out the faults without human interventions. I think that's the message I'd like to leave to the team. Vinita?
Thanks a lot, Joe. Thanks a lot, Joe, for the wonderful, wonderful insights into the challenges, and not just the challenges, how they can also be addressed. And everything is not lost. Definitely, with audits, with assessments, and using data science, things can also be controlled. So, thanks a lot, Joe, for taking time for this session.
Thank you,
I'll
Vinita.
thank you. So we'll move on to the next session by Mr. Sushil Kumar. Hello, Mr. Sushil Kumar. Thank you for joining this session on the security. A brief introduction of Mr. Sushil Kumar. He's an officer of the 1987 batch of Indian Telecommunication Services. He's currently posted as the Deputy Director of General in Telecommunication Engineering Center (TEC), and he heads the Internet of Things division from 2016. He's also the Vice Chairman in ITU Study Group 20 on IoT and smart cities and communities, as well as ITU focus groups on artificial intelligence, Internet of Things for digital agriculture. Mr. Sushil Kumar, the chairman of National Committee in TEC on IoT and SCNC, and as well in the BIS on IoT and digital twin. He is also the chairman of TEC National Committee for adoption of one M2M specifications transposed by TSDSI. Over to you, Mr. Sushil Kumar. Thank you for taking up this session.
Yeah, thank you very much. Uh, Please give me the sharing right for the presentation.
You can share, sir. In the bottom third, present to audience, then select entire screen, or it's nearby your mic.
Yeah, I got.
Yeah, we can see your screen now. Yeah.
Okay, thank you very much, and thanks a lot to TSDSI to give me this opportunity.
Sir, can you
To
make it slideshow mode?
Yeah, sure.
Thank you, sir.
Uh, Okay, it's a wonderful presentation by the previous speaker on 5G security. And I'm really thankful to TSDSI to give me this opportunity to express my views on IoT security. So I'm from Telecommunication Engineering Center. This TEC is basically the telecom, this standard body for the DOT on telecom and ICT related activities. And it is also designated as a national inquiry point for WTO-TVT, that is technical barrier to trade for telecom sector, mandated to coordinate with the ITUT and having national working groups in line with the ITUT study groups. It is also designated authority to implement the mandatory testing and certification of telecom equipment that is very much required to ensure the security and safety of the telecom and the IoT devices. And it is also the designated authority to accredit the caps. This is one of the pictorial view of the IoT domain, from the sensor and devices to network and then to platform. And the security is required in all the items of the IoT domain, from starting from device to network gateways and these platforms are mainly the software entity and it will be in the cloud. So for this, the standard-based solutions are required. And as we know, this in IoT, there may be a number of communication technologies depending upon the use cases, starting from NFC, BLE to cellular, non-cellular, and even now on 5G communication technologies. So this is basically a pictorial view where in the red circle we will be having the gateways, and gateways should be IP enabled, and the devices behind the gateway may be IP or non-IP. Then, as the 5G is being deployed across the country and across the globe, now we'll be having a large number of devices to be connected on the 5G technology, as it will be having the massive machine type communication as well as the ultra reliable low latency services. And 5G is mainly for the vertical industries, and that is for the IoT domain. So 2/3 of the 5G will be used for the IoT, and most of the use cases will be which are not practically possible in the previous generation technologies, and will be possible in the 5G technology like Industry 4.0, then cellular V2X, and we can have robotic surgery, and so many critical use cases will be available in the 5G. But the security is required to be maintained for the 5G technology also, because a lot of elements will be shifted to the core, to the cloud. The 5G core will be in the cloud. Then we will be having the AI and ML algorithms, not only in the clouds, but it will be available on the roadside units, or the we can say the BTS for cellular V2X. We will be having the roadside units deployed across the cities, and where the AI ML algorithms will run. So the security is required to be ensured in all parts of the communication technology, as well as the devices, and also at the platform. Now, the DOT has released a number of policies for the proliferation of the IoT domain, and the National Telecom M2M roadmap that was released in 2015, and this NDCP, it was released in 2018, and a number of circulars and guidelines have been released in the last 5 to 6 years. Then TRI has also released its recommendation in 2015, and those recommendations were accepted in toto by DOT. And two of the work items which are related with the device security, they were sent to TEC to carry forward the work. These are like the device manufacturers should be mandated to implement the security by design principles in M2M device manufacturing, so that end-to-end encryption can be achieved. And the second one is in National Trust Center under the aegis of TEC should be created for the certification of M2M devices and applications, hardware and software. So hardware will be tested in MTCT, and the software can be tested. Software applications can be tested by STQC, and other software may be tested in the labs. This ITSAR is being developed by the security wing of DOT in Bangalore. Uh, uh, Therefore, testing and certification, that is the prime requirement of the telecom equipment as well as the IoT devices for ensuring the security. Then further in the NDCP, which was released in 2018, these are some of the very important items related with the IoT domain, like delivering market for IoT M2M connectivity services like sector, including agriculture, smart city, intelligent transport system, crowd management, multimodal logistics, and others, simplifying licensing and regulatory framework, enabling high-speed internet, Internet of Things, and M2M rollout for 5G technologies, developing framework and accelerated deployment of M2M services while safeguarding security and interception for M2M devices. So these are some of the points which are taken from the NDCP 2018 related to the IoT and its security. Then TEC started working in M2M IoT domain sometime in 2013-14, and with the association of the industries, academia, and standardization bodies in multi-stakeholder working groups, we can say, and released 18 technical reports so far. These reports are in power sector, automotive, healthcare, smart cities, smart home, smart village, and agriculture, communication technology, security, etc. And some of the key points, like 13-digit numbering scheme, which is being used by the TSPs for SIM-based devices, that was developed in TEC, embedded SIM, IPv6, or dual stack for all devices, gateways, common service layers. Large number of points which are the part of the policies and the standards. They are the outcome of these technical reports. Three reports are related with the security. That is the framework for National Trust Center for testing of M2M devices and applications, released in March 2022. In fact, when we started working on the TRI work items, which I mentioned in the previous slide, the first two documents, they are the part of result of the study of the on TRI work items. That is a framework for NTC and the code of practice for securing consumer IoT. However, the studies is still in progress, and we are expected to release the complete document by December 2022. And M2M IoT security, it was released in 2019. So DOT has taken a further step and issued the office memorandum in July 22 to all the ministries of Government of India, DRDO, and telecom service provider with request for wider circulation of code of practice for securing consumer IoT to all related stakeholders like the IoT device manufacturer, service provider, system integrator, application developers, etc., for voluntary adoption of the guidelines available in this document and provide feedback. Because you cannot mandate anything overnight. First, the things should be voluntary adopted, and these are very important from the security point of view for the consumer IoT devices. And after some time, some of these guidelines can be mandated. Then security by design work item, like these two work items on on which we are still in work. Work is still in progress, and the NTC framework, National Trust Center framework, the document has also been released, and this work has been awarded to CDOT by NSCS for creating a portal and for doing this pilot project for verticals as well as for the smart cities, because all the platforms, they are supposed to detect the vulnerabilities in the IoT devices, like it may be a camera, it may be a tracking device, or any other devices. And the M2M service provider registration policy, which has already been released by DOT, and more than 100 M2M service providers, they have already registered with that. So now it will be required that the if any vulnerability or security related issue arises in the device, then the platform should be able to detect that one and should able to manage the vulnerabilities or the security related issues, and further communicate to National Trust Center. National Trust Center will intimate to the manufacturers or the researchers, and the further the manufacturers should be able to develop the patches or the software and update over the air for that. And there are from this study, the entire presentation is from the study which we are carrying out. There are so many hacking events across the globe for the IoT devices, uh, like a smart meter, then the Foscam IP baby cam, BMW connected car vulnerabilities, Mirai DDoS, man in the middle, and so many type of vulnerabilities may arise in the devices, in gateways, or in the smart cities, or in any vertical industries. Then what may be the consequences from this? There may be a traffic management systems, jams and accident, V2X infrastructure, fatal accidents may be there, smart street light may also be hacked. This pilot was done by Qualcomm in some of the US university, and they presented in one of the webinar organized by TEC. Then smart parking jams, network infrastructure, data center denial of service, then sensor and alarm system, panic, stampede, and rioting. Such type of things may happen. This is a survey done by the IoTSF, Internet of Things Security Foundation. They have done this survey for around 332 IoT device manufacturers, and they found from 2018 to 2022, only there was very small rise of the device manufacturers uh, who who provided the vulnerability disclosure uh, statistics, and they are having the policies for vulnerability disclosure. And this survey was done for the IoT manufacturers for the North America, Europe, and Asia. So this is a really a very surprising situations that the device manufacturers they feel that the security may be the last option for them, and now it is required that some sort of guidelines would be mandated by the regulator or the policymakers, at least for the vulnerability disclosures. This ITU has also defined privacy and security, one of the important item for the proliferation of IoT ecosystem. It's a big challenge, and ITUT Study Group 20 as well as Study Group 17, they have released a series of standards on this. Some of these standards are mentioned here. And one of the most important standards, that is the ITU TX.509 for creating the secure certificates. It is being used from the last more than 30 years, this standard, and so many other standards have been released. Similarly, ISO IEC JTC1 SC27 has released one standards recently in 2022, that is cybersecurity, IoT security, and privacy guidelines. This is a very important standards. Then ETSI cyber released ETSI TS103645, that the security for consumer Internet of Things baseline requirement. Then same was adopted in 2022 by European Union. Similar, based on these principles, UK is already having the consumer IoT security guidelines released in 2018, Australia in 2020, and India released in 2021. Finland and Singapore, they adopted its CEN 303645 as a baseline standard for creating labeling scheme. That is also very important. Singapore is also having MOU with Finland as well as Germany for the product based on cyber security labeling scheme. So now this is, in fact, in a number of conferences, the NCSC coordinator, this National Cyber Security Coordinator, Lieutenant General Pant, mentioned that India is not having any guidelines as well as the labeling, which is very important for the cyber security. So this is one of and the code of practice was released in 2021 by TEC, and after a lot of study of the standards and the best practices across the globe. This is one of the slide out taken from one of the document of Singapore. This level 1 meet baseline security requirement. It is based on 303645. Then level 2 adherence to international standards, and level 3 and level 4, they have categorized the devices in level 1, level 2, level 3, and level 4. Now, similarly, GSMA has released the IoT Safe, which is a very important standards. Use the SIM as a mini crypto safe inside the device to secure, establish a DTLS session with a corresponding application cloud server. Is compatible with all SIM, provide a common API. Similarly, NIST has released a series of standards and guidelines on IoT security. IEEE IoT SF 1M2M TS0003, that is on security solutions. So we should use all these standards and guidelines for improving the security of the IoT domain. IoT device hardware, which is required to be tested under MTCT, but MTCT it is being implemented in phased manner, and therefore any of the device which has been deployed in the network may become vulnerable, whether it is tested or untested. And to facilitate the IoT device ecosystem, IoT network, the National Trust Center has come into the picture, and this National Trust Center, which I mentioned that it is being implemented. The portal is being created by the CDOT. The work has already been awarded to them, and it will help in managing the vulnerability and security related issues. So all the platforms connected to the NTC, they will be transferring the details on open API. And NTC portal will find out the manufacturer from the repository and communicate vulnerability to the manufacturer to get it mitigated. The experts, researchers are also expected to study and mitigate the vulnerabilities. In fact, the NTC should also have the repository of the vulnerabilities which are created time to time. It will help for further research. So NTC framework, which was released by TEC in 2022, and we hope this implementation will be over in the next 1 year. Then, in my view, at least the first 3 guidelines of the TEC technical report, that is the code of practice for securing consumer IoT, will help in managing vulnerabilities and securing consumer IoT ecosystem, like no universal default password or banned default password. Second, they implement a means to manage report of vulnerabilities, and the third, they keep software updated. Like the online updation facilities would be available to the manufacturers, and manufacturers would also have the arrangement to implement the means of manage reports of vulnerabilities. And these 3 items should be the part of the policy, and these are required to be mandated. Vulnerability management should be a part of policy and mandated for IoT device manufacturers or the importers. security by design principles for IoT device manufacturers. These guidelines will uh, are expected to come by December. The secure onboarding of IoT devices at the platform using X.509 certificates, classification of IoT devices depending upon the risk associated with the applications like the Singapore, Germany, and the Finland. They have done is also in the process of providing this IoT device labeling scheme, testing of IoT devices against security guidelines as it's C103645, and testing and certification of IoT platform, because most of the IoT platforms are proprietary, they are non-standards based, and whether the security arrangements are security features are being built in or not, nobody knows. So the IoT platforms as well as the 5G core are required to be tested against the specifications, related specifications. So these are the points from my side. Thank you. Thank you very much.
Yeah. Thank you, Mr. Sushil Kumar, for the wonderful session of getting to aware of the challenges that can be in the IoT side. And it's not just that, the guidelines and how we can also, ensure that we can take care of these issues with various guidelines, and maybe initially it can be voluntary for people to adhere to these guidelines, and later on we could make it mandatory. Thank you for the wonderful session. Um, are there any questions here that we have to flash or something? Sorry. Yeah. Do we move to the next session? Yeah. Thank
Chair,
you.
we have questions
Yeah.
two questions received. If you would like, we can take them here now or at the end of the session.
Yeah. I think maybe we could take them now.
Okay.
Yeah, I think
Maybe.
we should do it now.
Yeah.
The first question is on the screen. So it's for Mr. Joe. Can you please share your comments on security considerations and security standards for metaverse, AR, VR, immersive aspect?
Do I answer now or should it be answered now?
Yes, Joe. Yes, Joe.
Okay. I think this is going to be one big area which I said on the radio access side, which is going to make this very complicated. One, from a perspective that the radio networks are going to open out more of these protocols. I think most of the applications, the newer age applications, have secure hashing mechanisms within the protocol, within the application, which can make it slightly more contextualized from a security perspective. I think within the protocols also, there's some amount of hovering on the protocol, on the security packet sniffing, packet management is also in place. So there is some kind of thing already available. I think the place where I think we're going to have this problem is when you try to have all of this onto one common portal and have that transferred out. There we may face some problems, but otherwise I think there will be challenges in the initial part, but I feel that the existing security mechanisms are good enough to actually manage it.
Next question on that screen.
Yeah, I think very valid question. If you look at the whole of the security when it comes not only from SDN and 5G packet core, it starts from the NFVI area itself. From the moment you are virtualizing the physical storage to virtual, and from there to having the virtual switches, I think from there the journey starts. It's a little complicated. I think we have there are frameworks today available to secure that part of it. When it comes to the user plane, I think it's a little serious matter because you have a lot of this sniffing going on between the control plane and the user plane. But just the user plane, you don't have to worry much. You can manage it. But the transition of packets between the control plane and the user plane is a little tedious. I think what I would suggest is that you could put up a virtual firewall there with an IDS integrated, and if you can orchestrate the application the respective application through the firewall, then there is a way to handle it. On all NFVI and SD networks, if you can orchestrate the applications through the firewall, it takes off most of these issues. But if you were not to orchestrate the application through the firewall, but leave it to the respective operators to handle it, it gets really critical. Because one POC we did for the government of Malaysia, where we tried both, and I think the ones which applications which were triggered through the firewall or which were launched through firewall were more effective than having a mid firewall place there.
Okay. Uh, Thank you, Joe. I hope this is very interesting insight, Joe. Thank you. I think with the sake of time, we'll move on to the next session. Yeah. The next session is by Dr. Manikantan Srinivasan. Thank you, Dr. Manikantan, for agreeing for this session. A brief introduction about Dr. Manikantan is he currently works at the NEC Corporation India Private Limited, and he holds the title of Assistant General Manager. At NECE, Dr. Manikantan is involved in cybersecurity intelligence, cybersecurity threat, telecom security, 5G, and beyond related research. ORAN Alliance architecture based on 5G solution development and the 3GPP standard initiatives. Over to you, Dr. Manikantan, for your session. Thank you.
Hi. Thank you, ma'am. Thank you so much. Let me just share my screen in a minute. I hope my screen is visible, shared screen.
Yes, yes.
Okay. Good morning and warm welcome to everyone who is listening into this conference. I thank the chair and all the other speakers, Mr. Joe and Mr. Sushil Kumar and panel members. It's certainly an honor, as Mr. Sushil said, to share this floor and to share some insights to the larger audience. In this short time in which to cover a large set of information, I'll try my best, and I hope this will be just teasers or pointers that will help you to dive further in and get the details. So my talk is going to be on the quantum side of the security part of it. So how that is related with respect to the telecom world. I have made here no assumption on the background of the audience, so I hope the steps that I take you through will help. On the very first slide is we talked about security and why is it pretty much mandatory or required. From a security, we protect an asset means it is a data. This data could be like a secret design that we make for our product or for our country or even our own data which is in the bank. So this asset needs to be protected, which means and then it should not be changed and it should be available. So when it is protected from unauthorized access, it is basically to ensure the confidentiality. Value does not get changed is the integrity part of it, and then made available to you whenever is needed. So these three are the pillars of a basic security, which has various ways in which it needs to be protected and applied. Here I want to highlight on two aspects, basically this encryption related part and then this authentication authorization, which are the core components of the cryptographic algorithms that I'm going to talk about in the subsequent slides. So sorry, please note. So we are going to talk more deal with respect to encryptions, decryptions, and the cryptographic algorithms. So this is a general slide. Now moving further to the next one. Now is data can be in rest, which means where it is stored, or the data moves. Like what was said by Isaac said, it could be in the user plane of the 5G network. When the data flows, also it needs to be secured. One way to secure it when the data flows at rest or in motion is by using a symmetric encryption algorithm, and there are various symmetric encryption algorithms today. So, what is symmetric encryption algorithm? A sender and receiver both use the same encryption key and the encryption algorithm to handle their communication. Sender sends the plain text encrypted using a key. it becomes an encrypted text, and the receiver uses the same key, runs through the decryption algorithm, and gets back the plain text. This is an efficient way, especially when the amount of data to be sent is very, very large. So symmetric cipher is, most of the communications are done using symmetric cipher. So, but if you observe, both of them must have this common key. This is the fundamental challenge in the symmetric algorithms, where both sides should have this key only known to them and no one else should know. So this is one of the challenge, and this challenge is actually solved by this asymmetric ciphers, which was initially started by the RSA, Rivest, Shamir, and Alderman. So in asymmetric cipher or public key cryptography, there are, each member has two keys. So there is a private key and there is a public key. So and Alice and Bob, when they want to send the data, when Bob is to send data to Alice, he will use the public key of Alice to encrypt the data. And for to make Alice really know that it was Bob who sends this data, he will sign it with his private key. So please note, we use both private key and public key with respect to encryption. The private key is used typically for signatures. Public key is used for sending of this data. So, asymmetric ciphers overcame the fundamental problem that is faced in the symmetric encryption algorithms of everyone knowing well in ahead the common key. Um, so this is, we have various cryptographic algorithms on this, such as RSA, ECC, Elgamal, etc. And establishment of this key is done by algorithms such as Diffie-Hellman to help with that. So now, as I had explained, the one of the fundamental feature, that brings strength to this uh, public key infrastructure, or the public key based cryptographic today, is based on a mathematical concept which says that one cannot figure out a private key only when they know the public key. It hangs on a mathematical concept called computationally infeasible using the classical computers. Okay, so this is the key, or the very basic part. Moving to the next slide, just a couple of key terminologies. There is a key encryption, that is the data that has been encapsulated. This is the key encapsulated mode and data encapsulated mode. Whenever a data has to go from a sender to receiver, we have these two terminologies. I bring this as a reference because we'll be referring to it later. Sometimes, before we exchange the data, we will agree upon the symmetric key. That what PKI helps, and you can have a per session key to handle it. And when you receive the data, and how do you decipher it? Sometimes, along with the data, you can send a very specific key that you have used to encrypt, which has would have been encrypted using the public key. So the receiver, using the private key, can take this symmetric key and decrypt the encrypted data and to proceed with it. This is what is being used everywhere today's in complete deployment. And please note, I emphasize this is been successful today because the computational intensity challenge is based on the classical computers. Now, we enter the phase of quantum computation. And this started somewhere in the early 90s. So we are now covering a field that has been covered close to 3 decades. When Feynman indicated that we can use quantum computing and create computers, the primary benefit is the power of computation significantly increases because of this concept of qubit. In the classical computer, we have digital digit, or the bit binary digit, or bit with zeros and ones, whereas here in the quantum state, here we have the qubit, the qubit, which could be a photon or it could be an ion in a particular state. We can various ways you can derive it. It can be in any of the two observable states. Okay, so ideally it can have two values, and probabilistically you can get either a 0 or 1. uh, so this the way in which the information held by a qubit. For single qubit you have two values. When I have two qubits, then I have 2 power 2 4 values, and when I have 3 qubits I can have 2 power 8. So basically when I have many number of qubits, my amount of space or the amount of options in which I could have the values and becomes very large. So qubit, short form for quantum bit, which can be either in the state of 0 or 1. It's basically, you can consider it as a photon or a part of light a particle photon, which is in a revolution, which is in a waveform or as a particle. It could be spinning in a around the z axis. It could be pointing upward or in the down, and when we make a measurement we can figure out whether it is pointing up, which could be like a 0, or pointing in the other direction, which could be 1. And it will be 0 with a probability of alpha square, and with 1 with a probability of beta square. Sum of their probability equals 1. This is for a single qubit. um, we can have multi-qubit systems. The first one is example where there are two qubits, which means the qubit 1 in a value 0 and the qubit 2 also value 0, the overall with a probability alpha squared, in this state with alpha squared. Similarly, you have other combination, sum of all probabilities becomes 1, and you have a n qubit computer you could create. Now, when quantum computing was identified, it then gave rise to quantum algorithms. And some of the quantum algorithms that brought a fundamental change in our thought or a paradigm shift. The first one is by Peter Shor. So, Peter Shor came up and saying that there can be an effective way to factorize a given number. If you remember, I initially emphasized the public key cryptography was based on a mathematical concept or the computationally intensive to find the divisor of a large number. Peter Shor in 1994 showed that um, we can, in a very short time, find the divisors of a large number. This brings in the breaking of our public key infrastructure or a PKC mechanism. So Peter Shor's he is one of the quantum algorithm from Peter Shor, is the fundamental change. So this breaks the asymmetric cryptographic mechanism that you have been dealing with. Another fundamental, so this slide, sorry, before going to that, this slide which should give you a sense of it. For example, I can have two large prime numbers whose product is another large prime number. These prime numbers are the ones that form part of the RSA algorithm to generate my private and public keys. Now, even if I have a 300 digit number like this, now this is a 129 digit number. If I have a 300 digit number, in a classical computer, it will take 10 power 24 steps, which is like as shown here 1,550,000 years, whereas in a quantum computer it could be done in 1 second. Basically, Peter Shor's algorithm showed that compared to a normal way in which you could factorize, using his algorithm, which was in a super polynomial speed up, it could be achieved. So this puts us into the danger zone. One question we can ask: do we have such a solution today? Actually, solution doesn't exist today. People are building large qubit quantum computers, but potentially it can be done. So if that computer could come 2030, 2035, 2050, then all the public key based solution that we have created today are under danger. So second paradigm shift similar to that is an algorithm derived or found by Love Grover. His algorithm identified an effective way to find information in a large data set, which is not necessarily be a structured data set. So his algorithm impacts symmetric ciphers and hash algorithms. Okay, so while Shaw's was on the asymmetric, Grover's has an impact on symmetric and hash algorithms. So now we are forced to look for ciphers which are quantum safe, which means any of the security certificates like what was mentioned, and even I'll be saying later, the newly evolving the 5G all the networks, the current ongoing communication between the NFV elements, the network virtual function elements, VNFs, are user authentication is using public key and a private key. These are today vulnerable. One question you could ask: suppose if my exchange is done within today, it is no longer required tomorrow, which means if my confidentiality has to be on for a long drawn, which means I have encrypted some information today which needs to be there for 50 years from now, then that needs to be protected. So that is also is what we are looking as a concern. So these algorithms that has been made using all these public uh, all these PKIs, public key infrastructure or public key um, cryptographic base, they are under challenge today. Now, it's not only that, as I said, a symmetric key such as AES can be broken by Grover's algorithm. Okay, but one thing is um, the strength of the cipher is based on the size of the key. Simple example that you can see is in your house you can have a 7 lever lock. Now if you make an 8 lever lock, the lock is pretty strong. Similar here, if I have a key of size 128 bits, I double the key size, your encryption is pretty strong, you can't guess kind of a stuff. So a basic or a high level definition: quantum safe cipher, a cipher which means the encryption algorithm. A cipher is called quantum safe if it can adapt to a quantum attack. How it would adapt it by increasing its key size, so that it can overcome the vulnerability which is introduced by the quantum computing. AES as on date is AES 128 is considered quantum safe, which can be utilized. So, according to ETSI, ITSI, one of the standard SDOs, the quantum safe cryptography means the efforts to resistant. We are trying to find algorithms which are resistant to attacks by both classical as well as quantum computers. Okay. Now, how are we doing it? Once Peter Shaw's algorithm woke all of us that public key cryptography is a challenge, there were there are a set of families or ways in which we can derive the keys. The earlier one was mathematical challenge was leveraged, computationally problem was leveraged. Now we have other ways of deriving these particular keys. Yeah, one of them is code based schemes where you have to find the closest code word or the shortest error vector. This is a challenge. So we are building where keys can be derived using code based schemes. Within that, there are two categories. This scheme is good for creating your the key, both the data to be encrypted and then handle key encryption mode as well as your data encryption mode. The others is lattice based. So in this lattice, it is to find the vector which in your space to find the vector which is basically relatively short and close to your some target vector. again, there are two categories over here. This lattice base can be used for both encryption decryption related part as well as for digital signatures. Then you have three others, which are multivariate schemes, isogeny, which is deriving from elliptic curve cryptography based, and then lastly symmetric schemes. In addition to these five schemes, one can also share key using quantum key distribution, QKD for short. So this has been one of the ways where using transmitting your photons, you can transmit your key from one side to the other, sender to the receiver, which is there. However, it has lots of challenges to create those transmitters and receivers and to get the key. So, meanwhile, these five families based algorithms are work in progress, and I'm talking about this because this is based on this is where new cryptographic algorithms have been proposed to NIST. So, where are we today? Once we found that the public cryptography is in challenge, then NIST, which is the standards body ensuring all safety, especially in the US, announced that they would want to identify new algorithms. AES, and similar to AES, how can we replace other things? So in 2016, they called for proposals for digital signatures as well as public key encryption schemes, and then key encapsulation mechanisms that will be quantum safe. So they are called for members to contribute, and in 2017 there were 69 contributions from across the globe. Out of which there was 20 were for digital signatures and 49 for the public key encryption schemes. Um, Immediately, five had challenges. So, end of the first round, there were 64 candidates. These 64 proposals were analyzed, and in 2019, NIST announced 26 candidates are progressing to the second round of evaluation, out of which 9 were digital signatures and 17 were PKE schemes and KEMs. Now, very recently, in the sense like July 2020, NIST has announced the 15 candidate algorithms, out of which 7 finalists and 8 alternate candidates exist, who among which will be identifying the final ones. The 7 finalists has 3 digital signature schemes and the public key encryption schemes. Please note, when we use symmetric cryptography, it is pretty much helpful for faster encryption sending data, but to creating situations of non-repudiation or you are the owner is typically not achieved in symmetric cryptography, and public key cryptography helps in that particular manner. So in this slide, I have brought you the highlight of what are all the candidates. Uh, if you notice here, this is the family that I talked about under the various code-based category, lattice-based, and multivariate-based. The various schemes that are currently the candidates. Okay, now I'm shifting gears, coming to our 5G mobile networks. Just a quick view for people who even may not know about the this one. You have data going in three broad planes, or today maybe four planes in 5G cellular network: your user plane, your control plane, your management plane, your synchronization plane, where time synchronization signals are sent. In every plane, the data needs to be secure. The components that play, which has been expressed by both the earlier speakers, Mr. Sushil and Joe, how they say that they are valid entities, and then they transmit data. And this 5G network has been ensured that at every release, things are being taken care. Just snapshot of 3GPP's plan on the release in terms of what are the features that they have
Dr.
been working on.
Manikandan,
Yes,
sorry, yeah, I think we'll have under 5 minutes, please.
sure,
Yeah,
yeah,
thank you. Thanks.
sure. So basically, the we have the challenges in terms of handling the subscriber and the network security access, and ensuring that we have a key agreement part of it. So 3GPP has done how this quantum impacts the security for the asymmetric cryptography and the symmetric cryptography and the hash functions. So this has been captured in the 3GPP technical report 33.841. Now, what is so one people can ask, are we really in a concern today? Maybe it's not as bad as a 4G network has been pretty strong. There have been new cryptographic algorithms has been put in place in 4G. The same is what has been used in 5G, and 3GPP SA3, which is the standards group working along with ITSI Sage, are waiting for the NIST finalization to bring in the newer algorithms into the 5G networks. Okay, so once NIST standardizes the algorithms, excuse me, along with IETF, these post quantum cryptographic algorithms will be put into place. Also, how to transition is being done at ITSI. ITUT has a standardization group to work on it, and 3GPP taking care. So, to conclude, quantum computing has brought in a challenge that the cipher could be broken, and this quantum safe cryptography is being evolved, and cipher is being designed for that it could handle the quantum attacks. NIST is in the process of finalizing the quantum safe algorithms, and the telecom standard bodies are defining how you will migrate. Also, they are waiting for the standardization and apply it, and bring it into the implementation. With this, I conclude. I thanks for the time provided and for your attention. Thank you.
Thank you, Dr. Manikantan, for taking us right from the basics of quantum computing to what is being done by the standards body, and and how we can have a quantum safe world going forward. Thank you. Thanks a lot
Thank
for
you.
taking time on this session, Dr. Manikantan.
Thank,
So
thank you.
over to you, Videsh, to for the next part of the session.
Yes, thank you, Vinuta. And thanks to all the three previous speakers who talked about 5G security, IoT security, and then very nice talk about quantum computing and the impact of quantum computing on 5G. So thanks, everyone. So now we have to look into the intersection of all these three aspects that we have been discussing, which is the 5G security, the IoT security, and the impact of quantum on them. So therefore, the title of this panel discussion is the impact of quantum computing on 5G enabled IoT. And we have an excellent set of speakers in this panel discussion. I'm actually honored to be part of this panel discussion with some eminent panelists. So with the first panelist needs no introductions, Mr. G. N. Nath. He is an officer of the Indian Telecommunications Service. He is currently working as a Joint Secretary, National Security Council Secretariat, with responsibilities for coordination in matters of cybersecurity activities by different entities of India in the government, public, and private sector. So thank you to Mr. Nath for agreeing to be part of this panel. Our next panelist is Mr. Jagdeep Walia. He is the General Manager and Security Consulting Lead at Ericsson and currently oversees network security engagements in the market area Southeast Asia, Oceanic India. He has been for the last 10 years working in the security domain with focus on managing client engagements, contracts, and fostering vendor relationships in network security. So thank you, Mr. Walia. So the next panelist is Mr. Magesh Kasturi. He is a principal cloud consultant and distinguished member in Wipro Limited and handles customers in cloud transformation, modernization, and migration programs. His technical expertise includes AIML, cloud, blockchain, metaverse, and big data. Thank you, Mr. Kasturi, to be part of this panel. Our next speaker is from the academics, Professor Sumitra Kumar Sanadhya. He's a professor in the School of Artificial Intelligence and Data Science and the Dean for Digital Transformation at IIT Jodhpur. Earlier, he has also served as the head of the Department of Computer Science and Engineering at IIT Ropar. His research interests include design analysis and efficient implementation of cryptographic algorithms and protocols. And he will uh, talk about post quantum crypto specifically in this panel today. So, thank you, Mr. Sanadhya, for joining us. So last, we have Ms. Vijaya Kamath. She is a senior IT executive with 27 years of IT industry solution management and project implementation experience. Recently, she has worked closely as an M2M service provider in various eSIM use cases like device tracking, telematics, connected cars, etc., and life cycle management of eSIMs. So thank you, Mrs. Kamath, for joining us. Okay, so I guess now we are in a stage where we could start discussing. So I should first go to Mr. Nath. So Mr. Nath, welcome to the panel.
Yeah, thank you very much. Yeah,
Yeah, thank
I'm
you.
audible.
Uh,
Yeah,
yeah, you are audible. Yeah. So, Mr. Nath, I will start with you. So, let me first start with the aspects of 5G security only. So, 5G will connect billions of devices with more than a billion people. So, can you highlight some critical security challenges in making 5G networks robust against malicious threats?
yeah, thank you. I think people have been talking about 5G security for quite some time now. And and we tend to repeat ourselves in various forums.
So,
So,
from
but
your perspective, what are the key challenges?
it's not that, and somebody was mentioning that. So I was saying that, you just can't get fresh insights. You have a fresh audience, so you give the same insight to the new audience. So, but the problems remain, whatever problems are there, you present it to, and then we discuss about that. So, I'll say, we have a very eminent panel and a very highly technical panel which is there. I'll bring a perspective which is from the National Security Council Secretariat perspective about what it is. One of the things what's coming up with 5G is, we have this five private networks that we're talking about. There are lots of private networks that will get deployed, and we could also have smaller players who would come up with their own solutions and who would start deploying that. So that is one scenario that we would have. Then the other thing that we talk about is that 5G would have a lot of distributed architecture with edge computes that is coming about, which is different from earlier 4G networks and other networks that we already had. Then we also talk of low latency applications where we have remote surgery and mobility applications which are coming up. We also talk of cloud security. So these are dimensions that keep coming up. And the other is IoT also, parallelly IoT also is getting deployed. So you'll have lots of this data that's getting generated, and then we talk in terms of how do you protect the data both in at the edge and when it goes into the cloud in transit. That is one. The other thing, new phenomena that will come about is data sharing and consent management that will come about, because we will start thinking about using this data for public good, and then we start putting in place mechanisms for wherever the data is getting generated, how do we actually give it to people, so that maybe using AI tools and all, some new applications could be developed. So then there are security issues involved with that mechanism and all of that. Then we are also, then a lot of stress now is on open radio access networks. So where we are talking in terms of vendor diversity and fostering vendor diversity, because there's been a consolidation that has happened traditionally in the telecom market, and we have multiple players that were there in the 80s and 90s. You find that they all consolidated into a few vendors now, and then we are thinking of now having vendor diversification again, and that's where the open radio access network comes. So where we are thinking of having smaller players coming with pieces of the architecture, then how do you ensure that these companies, which might not have robust practices within themselves, like if you have a bigger company which is having robust practices, they would come up with secure products. How do you ensure security of these pieces that are coming up, and the challenge that the telecom service provider has to ensure that each of these pieces is securely developed? How do you ensure that? So it means, what are the process that the company is following? Yeah, are there some standards for that, for evaluating the companies? the processes that they have, and evaluating the products per se. So these are all multiple dimensions that are there, and they're required to be addressed. Okay. So one is good is that 3GPP is talking about security, and we have had some sessions in this tech deep dive before we barged into this. I'm not. I mean, unfortunately I could not join in it earlier, but I assume that those aspects were discussed. That technically, what are these at the slicing or at the interfaces? What are those thoughts that are going into? And encryption was one thing that was being talked about last. So what technically that's going on?
Yeah.
I'll just mention to this group, and so that people are aware where we're coming from. One of the things is we understood that the 5G tech equipment or ecosystem has to be examined from how security requirements perspective. That's why we have been in touch with the National Center for Communication Security that's based in Bangalore. It's a unit of the Department of Telecom. That they should work on this prospect or on this aspect of coming up with security requirements for 5G network elements. I'm not, when I talk network elements, not hardware or software, but anything. It's a network elements. So they've been working, and we have funded a project along with IIT Hyderabad. So been working on coming up with security requirements for 5G network elements. So that is one aspect. Then we have also been, actively trying to cultivate the industry and academia to come up with security requirements for IoT devices also. It's very important, that now currently anybody can pick up a device without knowing if it's any security features. So coming with security requirements so that people know that I'm purchasing a secure IoT device. So that's one. And we had funded a project. I'll not say that it's been a very success story up till now. I mean, last 1 year we've been evaluating the work that's happened. But luckily, under the cyber physical systems of DST, uh, IIT Bombay has a technology innovation hub. They have got they're working on the IoT sphere. So there we have been exchanging documents, and we are trying to come up with some RFPs for project proposals for IoT security. Where one of the things that we're working on security requirements for IoT devices, maybe classification of devices, and that's one area that work is happening. The other area, and we are funding this, is the establishment of a national trust center. So we are funding CROT now. We have invited proposals, and CROT proposal has been approved. So we are funding CROT for coming up with establishment of a national trust center, and that is especially for IoT devices, registration of IoT devices, certified IoT devices, service providers, IoT service providers, and vendors, device vendors. So that would be a mechanism for doing that. So these are some of the areas. I think when you start working in all of these areas with active cooperation both from the academia and the industry, I think holistically we would be able to manage to a certain extent, the challenges that are coming up with all of this. One of the challenges, of course, IoT people talk of is updates and upgrades to all the devices. Currently, also it's a challenge. Now, how does that happen? How do you actually have a complete repository of what are the devices in place and whether all the devices have been updated or not? What is the device? What are the updates that is required for that? These are all challenges. I think this National Trust Center hopefully would help us in doing that.
Yeah, thank you very much for your remarks. So I think you highlighted the design security issues of 5G, and then what security issues will come when you try to implement those designs in real world systems. I will come back to you about these different initiatives that government has taken to encourage the security ecosystem in India. But let me just go to Mr. Valia. And then, so Mr. Valia, so can you highlight some key enhancements that have been introduced in 5G for ensuring that the 5G infrastructure is robust against the attacks that we have been discussing in this session? So, Mr. Valia, please unmute yourself.
Can you hear me?
Yes, please go
Thank
ahead.
you. Thanks, Viresh, and thanks to Sri Nandanatri for good insights into the challenges. And I think some of the key challenges that I would say the challenge that he highlighted, I mean, which you were kind of referring to, was that to have security by design to ensure that the products have relevant security built in. And then obviously the other aspect comes in is the assurance, which is to ensure that when the operators are deploying, then they are confident that the relevant security capabilities have been implemented and they've been tested to ensure the proper functioning of those security controls or functions in the network. And beyond that, the 5G being used for different use cases. One of them that being pointed out was, for example, for in private networks. I mean, and then you also have new concepts like edge coming up with 5G in terms of supporting, let's say, ultra low latency use cases. So I would say the good thing with 5G has been uh, that this generation, or 3GPP, started when it started with standardization. Security was always a focus right from the start. So you can say that security by design has been built into when it comes to, at least from a standardization perspective, when it comes to 5G. Having said that, I would say that 5G, from a security perspective, it is basically reusing most of the 4G security, and then it goes beyond and has several enhancements that are there to address gaps in the previous generations. For example, we had issues with the IMSI being sent unencrypted over the radio interface. We had issues around the user plane integrity not being supported. We had issues of false base stations getting attached into the network, and then there were also these legacy protocols like SS7 and diameter vulnerabilities that existed. Um, so these have been factored in by 3GPP when they started to standardize 5G security. And also, it's important to mention is that when they started to standard, they realized that 5G is going to be used for multiple use cases, which would have their own specific requirements. So how they addressed is that they divided basically the standardization in phase one and phase two, where in phase one, which is referred to as R15, is where they define basic baseline security requirements, mostly from example is like enhanced mobile broadband use case. Beyond that, in R16 and R17, they are defining security requirements for different other use cases. One of those, as was private network, which is called as non-public networks, which has been defined by 3GPP in R16 and then going forward in R17. And then also you have other use cases, for example, vehicular security, I mean, or V2X kind of security that is being defined also in R16 and R17. So basically, just to kind of give a basic understanding that's how the security work has been taken up when it comes to 5G security. Now, if we specifically look into the kind of enhancements that 5G has done, and here are some of those. I mean, there are quite a few. I mean, so I'm just going to list out a few of them. And if we look from a subscriber authentication perspective, we have now authentication, which is terminated in the home network. Uh, Compared to previously where it was done in the visited network, wherein you could that itself led to certain security gaps. The other enhancement has been, since we see that 5G will be used for a lot of IoT devices getting connected. And IoT devices, if you look at some of the devices, the form factor is so small that you could not have SIM cards being used. So that's where we have support for non-SIM card based authentication, which is useful for IoT devices, that has been introduced. The other area is subscriber privacy. That has been enhanced through introduction of mechanisms for encrypting IMSI, and IMSI is no longer used for paging, which again was leading to in previous generation to certain security gaps which could be exploited. Then we have from a vulnerabilities in the core, which was related to, let's say, the legacy protocols like SS7 and diameter. We now have a service-based architecture where we are using HTTPS now, and then here also we have a zero trust that has been introduced, wherein each network function, when communicating with other, has to authenticate and authorize. So we have concept like zero trust being already standardized from a 5G core perspective. Uh, the other is from a perspective of roaming. We have roaming security. The whole concept of trust has changed when it comes to 5G network. In 4G or previous generations, we assumed that the my roaming partner or interconnecting partner is trusted, but that is no longer the case, because I mean, specifically from a roaming perspective, there have been a lot of let's say attacks that have been launched from the interconnected roaming partner networks. And that is where in 5G now, we have roaming security that has been introduced, wherein you have an actual authentication or security that has been introduced both on the control plane and the user plane, to ensure that you could kind of filter out any malicious traffic on the control plane, or any attacks that are coming from the user plane. So that is from a roaming security perspective. Further, we have also integrity protection that has been introduced over the air interface, again, which is mandatory for the vendors like us from Ericsson or Nokia, whatever, I mean, to implement, but then it is optional for the operators. And lastly, even the key hierarchy is longer in 5G than in 4G. Because in 5G we have introduction of two more intermediary keys, which provide better separation and security. Further, in the last, I would say we also have false base station detection in 5G that is supported, which was something that has been increasingly being seen in the networks around the world. So now with 5G, you have a possibility to detect false base stations or fake base stations that are connecting. So therefore, I mean, I would say that it's safe to say that 5G is the most secured G among all the mobile generations that have we've seen so far, and the expectation is that at least from a standards and implementation perspective, it is ensured that you have these capabilities implemented by design. And that is one aspect which is in terms of look from a standards and perspective. I think in case we need to ensure the security of 5G networks, for that matter any networks, I mean, you have to go beyond just the standards and implementation. I think most important aspects are in terms of how these are implemented and how the networks are managed, monitored. I think that is another area which is beyond, I would say, 3GPP, but then it comes in from a perspective of that you need to be aware of what's ongoing in your network, and that is where you need to have strong security management policies and tools that needs to be implemented to ensure end-to-end holistic 5G security.
Yeah, thank you, Mr. Walia, for highlighting the key enhancements and pointing towards the security aspects that have been brought in 5G, especially related to the fake base stations and MC encryption. These have been very closely followed in the academic community as well. So very thank you to you. So now that we understand that uh, 5G has put security at the forefront, now let's look into what the quantum computers will bring into the picture. And there, I would like to go to Professor Sanadhya, and I will ask him that we know that the quantum computers will open a Pandora box, and Mr. Manikarnikan, he talked about some aspects of quantum impact of quantum on 5G security. But can you also highlight the level of maturity of post-quantum cryptographic primitives and whether they are ready to be utilized in 5G networks in particular?
Yeah. So thanks, Dr. Vireshwar and TSDSI for this wonderful session, of which I'm privileged to be a part of. As Dr. Manikantan was already mentioning, uh, We know from the 90s, I mean, to be precise, 94 and 96, when Shore and Grover gave their algorithms. So Shore essentially told us that uh, discrete log problem, on which we have a lot of current cryptographic algorithms based, will be broken in polynomial time. However, this is still, in a sense, theoretical attack, because we need a certain size of quantum computer to actually use that. Similarly, Grover talked about an attack which will essentially allow searching for an item in a much faster way than what we can imagine. So think about a situation that I have n things lying on ground, and I want to find out a specific one with satisfying certain property. So maybe the best way is I keep looking one by one, and I'll find it in essentially n trials. If there are n things, I'll need to search all of them in the worst case. Uh, However, what Grover said is that this can be improved to something like square root of n in quantum computers, with quantum computers. And the implication of this attack is that on symmetric key cryptographers, in symmetric cryptography, when I use a 128-bit secret key, it will effectively become only 64-bit on quantum computers. So these are the two things that trouble us in cryptography. The Grover's attack, which will break, or reduce the level of symmetric key security, and Shore, which will break discrete locks and factorization, which essentially means whatever public key cryptography which is being used currently will be gone. So the question now is, are we at a stage when we are already going to see a real life break of these public key algorithms? So fortunately for us, it does not seem that we have reached that stage yet. So if you look at the history of last few years, uh, I mean, Intel, IBM, Google, these big organizations have introduced quantum computers having something like, say, 49 bits, 49 qubits to, say, about 80 qubits. But we haven't even crossed, say, 100 or 150 qubits till today. So unless we cross a large barrier, we are not really threatening the security of public key cryptography, or even symmetric cryptography is being used today. So fortunately, we are safe from that point of view. However, the way the research is going on, and the physicists are predicting that by 2023 or maybe 2030, we will have large scale quantum computers. And once they are in deployment, the cryptography which is being used will be broken. In fact, I would like to quote a comment by Dr. Michel Mosca, who mentioned in a famous talk that there is a 1 in 7 chance that one of the fundamental public key cryptography algorithms will be broken by 2026. And there is a 1 in 2 chance, 50% chance, that one of these algorithms will be broken by 2031. So this is the prediction we are looking at. In just next 10 years, we expect, with a more than 50% probability, that one of these algorithms which is being deployed right now will be broken. And think about algorithms, or data which we want to keep secure for a longer time. So I still remember from my college days, uh, India was participating in this comprehensive test ban treaty negotiations, CTBT negotiations. And there might be similar such treaties in which the government is making a certain policy decision. There are discussions happening between various organs of the government, and government would not like to reveal these secret discussions among other governments or within the government to public parties for maybe next 30 years. And that's why we have official secret acts and rules like that. So suppose we are expecting communication keep to be kept secure for, let's say, next 30 years, and we are using the classical cryptography which is being deployed right now. It may be broken in next 10 years. So this is the time when we are already worried about, not right now, but in the coming few years, what is going to happen. So, although we have not been able to build quantum computers of that large size, which will practically threaten the security, they are already a threat for near future. And that's where comes the picture of, can we do something about it? And again, Dr. Manikantan was already mentioning about the NIST algorithm development program for post quantum cryptography. Now, fortunately, mathematicians have identified a class of problems which will not be solvable very quickly, or to be precise, in polynomial time, even when quantum computers come. And these are problems which are hard even for quantum computers. And basis these problems, we are now in a situation to design the algorithms. But again, coming back to what Mr. Walia and Mr. Nath were mentioning in the beginning of this discussion, it is not enough to just think about a small tool. It needs to be deployed in a setup, and that deployment will only happen if there is a standard developed for these algorithms. You cannot just have any kind of parameter being chosen by a different vendors, because then they will not be able to communicate with each other. So this standardization process has started around 2016, and it is going on till today. NIST has already reached from level, so they initially started in December 2016, and they asked for candidate algorithms to be given to them for public standardization. And this process, first round actually completed around December 2017 or maybe November 2017. And there were 64 submissions of various kind of encryption algorithms, key exchange algorithms, signature algorithms. This is precisely what we need in today's world. And very quickly there were attacks found on some of them. By attack, I do not necessarily mean that a practical break. What I'm saying is that the security level is not what was claimed in the algorithm. So a lot of these algorithms were removed by NIST in this competition. And then second round, third round, and fourth round went on. And this year, few months ago, NIST announced seven final algorithms which are being considered for standardization. And there are six alternate candidates for whom NIST wants further studies to be done, maybe potentially future standards. So this is the current state. However, we do not have these algorithms still in the final stage. NIST is believing that we will have these by 2023. And once the final standards are announced, deployment will start. And again, deployment is not very easy. It's not like an academic algorithm which you take and implement. If you look at the history of attacks on public cryptographic algorithms, most of the attacks did not happen because the algorithm was weak. Most of them happened because there was either implementation weakness, or there was a weakness in one of the inputs which were coming. Most likely, maybe say a true random number generator or a pseudo random number generator, which was not really so random is expected. And this led to a lot of attacks. So there can be many inputs or many parameters which are playing a role in final implementation or deployment. So these are still being studied, and this is where the current focus of researchers is. And we hope that in next few years we would have matured, and we will have deployment. So as Dr. Narendranath was already mentioning about CDOT as a trust center, it is actually very nice to see support of the NSCS and the great work being done by organizations like CDOT, which are actually taking a lead in the post-quantum crypto security already. They have begun to deploy some of these algorithms in a test case inside their products. So I'm very, very hopeful and excited that maybe in less than say 5 years, we will start to see the deployment. The next question you talked about was whether it is feasible on say various kind of devices which are going to be in 5G. So most of these algorithms, if you look at, these are based on essentially four kind of problems. Either they are based on lattices, where certain problems are very hard to solve even for quantum computers, or they are code based, or they are isogeny based, or hash based. So this is the four classes of problems on which post quantum crypto algorithms are essentially fundamentally based on. Most of the algorithms that we study are actually in these four classes. Now, lattices are still good to deploy even on small devices. But code-based algorithms are so heavy in some sense. The key sizes are something like, say, 10 kilobytes or 100 kilobytes. So you certainly cannot fit in these kind of algorithms in small devices, which are likely to be there in 5G networks. So we are still looking at the final decision on the PQC algorithms, but it appears as of today that at least certain lattice-based algorithms, or at least some variants of them, will be suitable even for small devices, lightweight devices, etc. So this is what I would like to present at this moment. Thank you very much.
Yeah, thank you, Professor Saradhya. Thanks for bringing out this aspect that 5G will be the enabler for Internet of Things. And even with the development of the existing security mechanisms with and complementary quantum safe crypto systems, it may be possible that many of those crypto systems may not be implementable on IoT devices. But that is true for our conventional crypto systems as well. And hopefully there will be some solutions there. So let me now go to our another speaker, Mr. Vijaya Kamath, Mrs. Vijaya Kamath. Um,
So,
so, yeah.
sir, I will be taking from her side. You can continue,
I
sir.
see. Okay, so that I got confused there.
Right, sir.
Okay, so now we are at the stage in our this panel discussion that we would like to understand the implications of quantum on IoT security. So can you please break down the IoT security aspects, how security is implemented in IoT, and what are some of the requirements, and then what will be the role of quantum in that scenario?
Right, sir. So, sir, majority if we talk about IoT, we have seen significant growth in numbers in IoT devices. From last year, it have grown to 18%. Now, the total devices connected in the network is 14.4 billion, which will increase to almost double 27 billion by 2025. So definitely, as you mentioned, that it will have an impact, and quantum will also have an impact on this. But as rightly mentioned by Mr. Walia, we are in 5G network, which is seeing the surge in the IoT devices connected in the world. We with 5G developments and the developments which have gone into the OS sided of the SIM card, where we have covered the previous 4G, 3G, and 2G network deficiencies with which were there, the security deficiencies which were there into the 5G. The new authentication algorithm is introduced, where the IMSI is not being directly sent to the network. There are pretty much encryption which is developed across 5G, which will protect the devices from vulnerability. But this is towards the SIM card only and the network only. Yes, as you correctly in the question mentioned, that IoT devices are still not protected, and as Mr. Sushil Kumarji mentioned, that TEC is coming with the code of practice, where they have highlighted 11 points to do the device certification and implementing the vulnerability in the vulnerability in the devices. So three they have guided three points for the industry to take up forward, which is first is password encrypted. The photo could be updated if we found vulnerability, and the device should be tested first before going out in the market. So countries are following norms to certify the devices before we export, but definitely we should have an when we import also, and when we produce for India also, we should have some certification in line, so that we could protect the threats in the IoT industry as the numbers and the quantums are growing on. Then, as Mr. Walia mentioned, we have encryption methodology on the card, on the network. CF is there, SUFI is there, and rest of the mechanisms are there. Then we can build multiple applications either on the card and on the devices, which could be on AES minimum AES 128, which is quantum effective right now. So we can have the applications encrypted, the data encrypted using the technologies, and we can matlab we can somehow till an extent could avoid the issues, vulnerability issues. But yes, we should have some guidelines, the research work which is going on parallel in the institution, to adapt in the devices the IoT framework structure, the application structure, so that all these issues could be avoided.
Yeah,
So we have together, like GSMA has included iSafe, how the data could be encrypted. So people, the manufacturers, the device side and the SIM card side should start adopting those standards and specification for better utilization of the already existing standards and the security which is there on the ground.
yeah, thank you. Yeah,
Right,
thank you
sir.
for bringing that perspective to us. I guess at this point we should try to see what are the some of the industry initiatives in this domain of enabling security in this in this discussion about 5G and IoT that we are looking at. So I will go to Mr. Kasturi. So could you please tell us about some key initiatives that has been taken by the industry for resolving some of the security issues, especially in the IoT domain?
Yeah, thank you. Thanks for inviting me for this panel discussion. So let me give you a brief answer to this question about some of the IoT related threats. So I would like to quote two reports. One from BlackBerry Trend Report 2022, which talks about top 10 security threat issues. And in that, one of the major issues that they have highlighted is the IoT security issues, be it application level IoT security issue or the network and infrastructure level issue. I will be explaining that in detail. The second one is from Singapore Computer Society, where they have published a trend report about cyber security, top five cyber security issues, and they have quoted IoT security threats in terms of how each client is like having unprotected data, or how unsecured storage services being used by third party in the IoT ecosystem. So they have quoted that as a key issue, as one of the top five issue with respect to cyber security. So quoting this to reference, you can understand that the importance and the emphasis on IoT challenges. So when I take IoT security issues, I can look into that into four different stages of security issues. One at the infrastructure level, which is at the physical device and physical infrastructure level. It could be on the edge client, or it could be on the IoT devices, be it a smartwatch or an IP camera or whatever it may be, but physically on the device level, which is the infrastructure level IoT security issues. The second level could be on the platform level security issues, where it will be, for example, on the edge or on the gateway, where it collects the data and send it to the cloud services. So at the platform level, there could be security threat issue that you need to address. The third level could be on the communication or the network level. So how you are using the network protocol, or how you are using a secure tunnel or an unsecured communication channel to connect with your IoT services, edge, gateway and cloud together. So how this is unprotected and how to handle it better, whether you need to use a data encryption mechanism when you are transporting, like data in motion, data in rest kind of ways that you need to take to protect the data during network communication. That is one part of it. The fourth level, or the fourth stage, is at the application level. So if you take a complete IoT ecosystem together, it could be from your organization level IoT services that you will be using, and also you will be using some third party legacy services and third party IoT services from external vendors, where you are already using it for a longer time. So some of them lack security updates, maybe patching would have not been done, or they are not very clear about the role based access that needs to be given. So it could be potentially unprotected. So in that, in your ecosystem, if you are bringing that services also, then definitely it will have a security threat to the overall IoT architecture. So these four levels of issues needs to be addressed, and that's where the emphasis goes on in the security challenges. Some of the examples which I want to give here about potential security issues could be like privacy, data privacy. Like after the GDPR and the PII comes into picture, where data privacy and how your private data being handled in a public domain need to be protected. There are various legacy IoT applications where literally this PAE or the GDPR was not handled, and they are enforced to do that because data privacy is utmost important. And in a public IoT system, you should not have unprotected data having your private data being there. So that is one of the important thing that needs to be addressed. Second, how your data storage and data transfer being done, be it both the network communication as well as the storage services that you are using in the cloud and in the edge. So how they are they have to be protected. How you have to use an intelligent security mechanism to handle the storage service to be protected as well as the network communication to be protected. This needs to be addressed. The next one is on how you are having a kind of autonomous facility or an auto healing facility to the entire physical infrastructure services. So if there is some potential threat, how to recover on its own and how to make itself self-equipped, make the system and services to equip itself to be self-secure to handle it in a better way needs to be addressed, so that you will have a modernized ecosystem in your IoT architecture. At the same time, you are addressing a long-term problem on automatically managing, preventing, and monitoring, reporting your security issues upfront, and that will help for the team on the ground to understand the criticality and act upon if needed manually or pre-program the services to enable the security features automatically. So this is the brief view that I want to give about IoT security in terms of the key principles, in terms of the key challenges, and the stages that you need to look into the IoT security. Thanks.
Yeah.
Back to you, Virish.
Yeah, thank you for giving us that perspective. So I guess now I will go ahead and go to each of the panelists for their remarks after hearing the different aspects. So I will let me go to Mr. Nath first. So Mr. Nath, you heard what 3GPP is working towards, what industry is focusing on, and what kind of maturity level that we have in terms of quantum computing. So now I would like to quickly ask you for a brief comment on, should we look into, so are we also looking into some India specific needs? So we are definitely working on these challenges on a global scale, but are there some India specific challenges that we should also look at?
Yeah, I think one of the things is what all the points pointed out by the panelists that we have got. As it's been pointed out, 5G is more secure than the early generations of that, and because there's an understanding that has come about, and one important point that was brought out is that zero trust is something that's been implemented across. That's very important. Uh, and there are also multiple enhancements that Mr. Wali had pointed out that is there. If you look at India specific, one of the concerns that we had is, one is having standards and, developing products as per standards. But then there is also an element of trust that we talk about. See, from where do these products come from? So standards are important. Then it's important that you certify, test against that, and then see that they are conforming to the standards and they're putting the place. And that is one level of assurance that you get. And that's a very important component of the assurance, because there's a lot of thought that goes in from different members. But then we also found that bulk of our equipment, comes from outside sources. And how do you ensure trust of the equipment that comes in terms of the intent that is there? That's where we came up with this National Security Directive for telecom systems, telecom services, where we have asked that we are also looking at the sources from where this equipment is coming in. So you could say that it's an India-specific solution that we are trying to address the problem, without actually going and saying, going for a negative list, coming up with a positive list of saying that, okay, this company we have evaluated based on certain parameters to say that this is as a company, a trusted source from where the products would come. And as a company, these are components from this are trusted. Not specifically looking at standards, which is a different dimensions, but looking at other processes in place that, governance principles that they have, the type of people who are there, where it is based out of, and internal processes that they have. So that is one thing that we have added here, and I think some of the other countries also looking at the system that we have put in place and to see if that could be replicated in their countries. Of course, it's a very elaborate exercise, involved exercise, but that's something because of the criticality and the multi-dimensional 5G deployments, multi-stakeholder 5G deployments, IoT deployments that are happening, that we felt that they should also be part of this whole security exercise.
Yeah, that is very important to note.
Yeah,
Yeah,
here
thank you
it
for.
is. Yeah, here is a challenge is that how do you ensure the security of the supply chains? We are
Yes.
doing some exercise, I think, but there is still some work to be done to actually work to find out how do you really ensure a robust supply chain.
I
Yeah.
see. Yes. Yeah. Thank you for your comments. Thanks. So let me go to Mr. Walia and take a quick comment about. So can you just highlight one major contribution that India is doing in the 3GPP domain in terms of 5G security, Mr. Walia?
Would say, I mean, so from a, I think what we have, at least from a India perspective, I think we're getting involved with the 3GPP standardization process, and there is more and more interaction that is happening. This is something that we have started, so it's hard to say. Okay, specifically we have. What we have brought out as a requirement towards 3GPP. So I would say it's hard to say, but then the thing is that this is something that has just started, wherein from an India perspective, we are taking more and more kind of getting involved with 3GPP, and as we go forward, we would see that these India-specific requirements are then also included as part of overall 3GPP standardization process. That's what I would like to comment in brief.
Okay, yeah, thank you very much. So I will also quickly go to Dr. Sanadhya. So Dr. Sanadhya, so are there any fundamental challenges in post-quantum cryptography with respect to implementing them on IoT devices? So can you just highlight one quick challenge that the participants in this panel discussion, or the people who are listening to them and interested in quantum computers, can take forward and work on that?
Yeah. So one of the issues that we already discussed was the parameter sizes. If you're looking for even say 128-bit security, the parameter sizes are very very large even for small. I mean say small devices, lightweight devices. So this is a very big challenge, and that's where we will have to not use just these PQC algorithms, but we will also need symmetric algorithms, which essentially will be attackable by Grover's algorithm. So essentially, if you want to achieve, say, for an IoT device, a security level of 80 bits, we'll be using 160-bit security algorithms, and probably they can be very, very fast. Fortunately, we have another line of algorithms in this direction, which is standardized in the NIST competition on lightweight cryptography, or LWC. So LWC is something that we can work on, and this is something that again I would like to highlight. As a country, we are not focusing enough on studying these kind of algorithms. There are very few groups in the country who are working in these, and being from academia, I would at least like to argue about closer collaboration between academia and industry, which unfortunately hasn't happened too much in India. So hopefully that is something we learn and probably invest more on it in future, and not necessarily in terms of the government support. Government support is actually very very good in many many situations. I would say that if somebody writes a good proposal, it is highly likely that it will be funded from one of the government agencies. My problem is actually the industry is not coming up to that same extent, and because industry is not coming, we are not in a situation where we can think about deploying algorithms. So probably that deployment and more study of practical attacks, which cannot really be done purely by academia, is where we are lacking terribly, and hopefully this is an area in which we will do further work.
Yeah, thank you. So, as a young member of academia, I also hope that this whatever you are suggesting becomes fruitful. Yeah, thank you. So, I guess we are out of time now. So, I will like to again thank you all the panelists for giving their views and highlighting the key issues that we have been looking into in the domain of 5G security, IoT security, and the impact of quantum on uh, 5G enabled Internet of Things. So thanks again to everyone. So I would like to go back to Vinuta to give a few concluding remarks and then close the session. Thank Thanks.
Yeah, yeah. Thank you all to each of the panelists for such a wonderful session where we talked about right from what's happening in 5G to make it far more secure, to the challenges, to how industry and academia, everybody should collaborate together. To just end the final note, I mean, across the complete session, we live in a world where we have multi-vendor, virtualization, 5G-enabled IoT world. It has its own set of security challenges. Quantum computers has further added to these challenges. But with methods such as design audits, security testing of networks as a daily affair, having IoT devices being security by design, having vulnerability disclosure being mandated by hardware vendors, having quantum safe cipher using lattice and code based schemes, we could have a far more secure way of communication and a far more secure world. I think most importantly that I took away from this whole session is I see a lot of collaboration between academia, organizations, standard bodies in India and globally, collaborating together, like somebody said, unlike before, to understand these challenges, define standards, define governance principles on hardware vendors to create a more robust supply chain management. I think all this makes us feel a healthy feeling that the right endeavor is being done so that we can have a far more secure 5G enabled IoT quantum safe world, which also protects the privacy with taking GDPR challenges into account. So I think with that, that's a small note that I wanted to just share at the end of this session with everybody. Thank you all once again for making time for this session.
Thank you.
Thank you.
Thank
Yeah.
you. Yeah, yeah.
Thanks.
Thank you
Thank
very
you.
Thanks.
much.
Thanks
Thanks,
a lot.
everyone.
Thank
Thank
you. Thank you.